The first warning is not an explosion. It is a pause that spreads through the Combat Information Center like cold water. Screens glow blue, air vents hum, and the track picture on the main display blooms with contacts that do not arrive politely, they appear all at once. For a half second, everyone wants to call it noise. Then, the pattern moves with intent. The symbols multiply, split, regroup. The room does not panic, but you can hear the tiny betrayals of stress. A chair leg shifting, a breath held too long, a fingertip tapping a console like it can tap certainty back into existence. The captain does not ask how many missiles you have. He asks a question that makes the space feel smaller. Do we still know what is real? This is Battletech Declassified. Modern Warfare Explained. Tonight is not about the loud part of war. It is about the quiet part that decides whether the loud part even works. Electronic warfare is the fight over information in the air. Not the internet kind, the raw physics kind. Signals, echoes, links, the invisible threads that tell machines where they are, what they see, and what they should do next. If a missile is a fist, electronic warfare is the hand that covers your eyes right before the punch lands. It tries to deny you information, distort it, or replace it with something believable enough to make you waste time. A drone swarm is not dangerous only because it is many drones. It is dangerous because it is a system. It senses, shares, decides, then moves as one. If you can fracture that system, the swarm becomes individuals, and individuals are easier to manage than a coordinated wave. So we are going to treat electronic warfare like what it is in the swarm era, not a side tool, but a core layer of survival. Most people imagine a swarm as a flood. The deeper advantage is ambiguity. A swarm can be many things at once: attacker, decoy, jammer, relay, scout. That mix is designed to force hesitation. Hesitation is not cowardice. It is the normal cost of verifying reality. The swarm weaponizes that cost by scaling it. One confusing track is manageable. 50 confusing tracks can suffocate your timeline. A warship's defenses are built on a chain of steps: detect, track, identify, assign, engage. If you disrupt any link, the whole chain slows. And in swarm math, slowing is losing. That is why the swarm does not need to destroy your radar. It only needs to make your radar uncertain at the worst possible moment. Think of the electromagnetic spectrum as a city of invisible roads. Radios drive on some roads, radars drive on others. Satellite navigation is a major highway. Data links are the bridges that connect neighborhoods. Electronic warfare is fighting inside that city. Sometimes you block a road with noise. Sometimes you build a fake detour sign that sends the enemy the wrong way. Sometimes you collapse a bridge so the enemy cannot coordinate traffic at all. The hard part is this: you also live in the same city. When you fight in the spectrum, you are fighting in your own living room. Every move has side effects. So the question is never just, can we jam? The question is, can we jam in a way that helps us more than it harms us? Is quiet intents. Jamming is the blunt method. You flood a frequency with energy until the real signal is hard to hear, like shouting in someone's ear so they cannot listen to anything else. Jamming can target drone control links, navigation receivers, and coordination channels. Done well, it can break the swarm's timing and turn a synchronized wave into staggered fragments. But jamming is loud. It announces that you are fighting, and it can reveal where you are. It can also splash into friendly systems and make your own picture worse if you use it carelessly. Jamming is useful, but it is rarely elegant. It is a hammer, and a hammer always risks hitting your own thumb. Spoofing is quieter and often more dangerous. Instead of drowning a signal, you feed a counterfeit signal that looks real enough to be trusted, like swapping the labels on 2 doors and watching someone run into the wrong room. Spoofing can target navigation by convincing a drone it is somewhere it is not. It can target tracking by creating ghost returns that pull attention away from real threats. It can target identification by making harmless objects look urgent. The power of spoofing is that it does not need to last forever. It only needs to last long enough to cause one bad decision, one wasted interceptor, one delayed engagement, one moment where the chain breaks. In a saturation fight, a single bad decision can cascade into 10 more. A swarm behaves like one organism when it can communicate. That communication is the data link, the swarm's nervous system. It carries updates, timing cues, target assignments, and sometimes even the leader logic that keeps the group coordinated. If you sever the data link, the swarm can fracture. A coordinated wave becomes many independent arrivals. The pressure drops, not because the drones disappear, but because they stop acting like a single mind. But severing a link does not always stop a drone. Many systems have fallback behavior. Keep going, return to waypoint, loiter, switch to autonomous mode. The moment you cut the leash, you learn what kind of animal you are dealing with. So the key question is not, can we cut the link? The key question is, what happens after we cut it? There are moments where the spectrum delivers a clean win. The swarm loses coordination, loses timing, loses the geometry that makes it overwhelming, and your defenses suddenly feel like they have room to breathe again. This tends to happen when the swarm depends on fragile synchronization. If drones need constant updates to arrive together, then denial can turn the attack into scattered pieces. Defense can handle pieces. Defense collapses under a single synchronized wave. The win may look boring. No fireball, no dramatic last-second gunburst, just the ship still afloat because the swarm arrived wrong. But every attacker learns, and the next wave often arrives with fewer strings to cut. Autonomy is the swarm's answer to denial. Autonomous drones do not need constant communication to keep moving. They can follow pre-planned routes, switch behaviors when signals disappear, and still arrive at the target area even in heavy interference. This is where electronic warfare stops being a kill switch and becomes a shaping tool. You may not stop the drones, but you can degrade their timing, widen their dispersion, and reduce the density of the arrival. That sounds minor until you remember saturation math. A defense that faces 30 threats at once may fail. A defense that faces 10, then 10, then 10 might survive. So autonomy does not erase electronic warfare. It narrows its promise. Inertial navigation is how a drone estimates movement without external signals. It uses onboard sensors to measure acceleration and rotation, then computes where it should be, like walking through a dark hallway by counting your steps. This makes drones resistant to satellite denial. If GPS is jammed, inertial navigation can keep the mission alive. The weakness is drift. Small errors add up, and over time the estimate can slide away from reality. Denial can still matter by forcing longer reliance on inertial navigation. The longer the drone must count steps without correction, the more likely timing and formation degrade. But drift is not guaranteed to save you, especially in short missions where modern sensors can stay accurate enough. So, you treat inertial navigation like armor. It does not make the drone invincible, but it does make simple jamming less decisive. Some drones do not need a conversation, they just need a plan. A pre-programmed route is a stored mission. Fly here, turn here, descend here, impact the target area. This creates the zombie problem. Cutting the data link does not stop a drone that never needed the data link. Jamming may still degrade sensors and precision, but the drone can continue inbound on physics alone. Electronic warfare can still help indirectly. It can disrupt final approach cues, force safer behaviors, or cause wider dispersion. But it may not create the dramatic swarm collapses moment people hope for. This is why defense is layered. You cannot build a survival plan on one method, especially against a threat designed to keep moving when it cannot hear. Every time you transmit, you reveal. That is the emissions dilemma. More radar power can mean earlier detection, but it can also make you easier to locate. Strong jamming can deny the enemy, but it also advertises your position and your posture. In a swarm fight, there is pressure to turn everything on. That pressure can be a trap. If you radiate too much, you may harm your own picture, overload your own team, and make yourself readable to an attacker that is probing for patterns. Good doctrine treats emissions like money. You do not spend everything at once. You spend when the purchase matters, when denial can meaningfully desynchronize the swarm, and when your other layers are ready to exploit the seconds you buy. There is no perfect rule, only disciplined trade-offs under stress. In gunfights, ammunition is a physical limit. In spectrum fights, trust is a limit. If operators and algorithms cannot trust the picture, everything slows. And in a swarm engagement, slow is the same as empty. Deception attacks trust directly. It creates ghost targets, hides real ones in clutter, and forces the defender to verify. Verification is wise, but verification costs time, and time is the currency the swarm wants you to burn. This is why the most dangerous lie is often the one you want to believe. Under pressure, you want the picture to simplify. You want the extra tracks to be noise. You want the weird behavior to be a harmless glitch. A smart attacker shapes deception around that desire. If trust collapses, the entire kill chain starts making expensive mistakes. Defenders do not rely on a single sensor. They cross-check. Correlation is the simple idea that if multiple sources agree, confidence rises. If one source disagrees, suspicion rises. They also harden communications. They hop frequencies, use redundant paths, and train for degraded operations. When you assume perfect links, a broken link becomes a crisis. When you train for partial links, a broken link becomes a mode you can fight in. They manage escalation. Instead of blasting the spectrum continuously, they use targeted actions at the moments that matter most. That reduces collateral interference and preserves options for later phases. The goal is not perfect vision. The goal is usable vision, fast enough and stable enough to keep the timeline from collapsing. Electronic warfare can absolutely change outcomes in swarm combat. It can fracture coordination, degrade timing, and reduce density, sometimes enough to stop an attack without firing. But it can also fail to stop what keeps moving without signals. Autonomy, inertial navigation, and pre-programmed routes shrink the miracle and leave you with a more realistic benefit. Seconds gained, confusion reduced, and a wave broken into pieces. So the real question becomes, what does this swarm rely on? And what happens when we take that reliance away? That is the mental model that keeps a crew calm when the picture turns noisy and the clock starts shouting. Next, we are going to step through the key handles defenders try to grab, the links, the timing, the command nodes, and the deception cues. Then we will see why the attacker keeps trying to remove every handle you reach for. Electronic warfare attacks a swarm in three broad ways: denial, deception, and disruption. Denial is noise. You make the signal hard to hear. Deception is lies. You make the wrong signal look real. Disruption is separation. You break the links that let the swarm move as one. Denial is the loudest tool. It can break drone control links, weaken navigation accuracy, and reduce sensor performance. But denial is also blunt. It can affect friendly systems, and it can announce your posture. Deception is quieter. It aims to shift what the swarm believes or what the defender believes. It creates ghost targets, false priorities, and wrong coordinates. It does not need to win forever. It only needs to win for one decision. Disruption is often the most valuable. If you can fracture coordination, you can turn one overwhelming wave into multiple smaller problems. You are not trying to erase the swarm. You are trying to remove its ability to behave like a single organism. A swarm is terrifying because of simultaneity. It is not just many drones. It is many drones arriving together, from multiple angles, inside the same short window. That is what overload feels like. Not the count, but the timing. Electronic warfare can change the outcome without stopping the drones, by breaking that timing. If denial and interference force drones into delays, detours, or cautious fallback modes, the wave becomes staggered. Staggered arrivals give a warship time to breathe. Sensors can stabilize tracks. Weapons can prioritize more cleanly. Interceptors are not wasted in panic. Close-in systems face fewer simultaneous threats. So the first goal is often not perfect blindness. It is desynchronization, turning one cliff-edge moment into a sequence of smaller moments you can survive. When people say cut the link, they imagine drones dropping from the sky. Real systems rarely behave that conveniently. Cutting the link usually changes behavior. It does not erase the platform. Many drones have a hierarchy of control. They prefer a link, but they can continue without it. Some hold their last command. Some return to a waypoint. Some loiter. Some switch to autonomy and keep going. That means the defender must treat link cutting as a test. It reveals what the attacker built into the swarm. If the swarm collapses into confusion, you just removed its biggest advantage. If the swarm keeps moving cleanly, you have learned you are facing a more resilient design. Link cutting is still valuable because even autonomous swarms often lose coordination without a network. The threat may not disappear, but its ability to arrive as a single overwhelming organism can weaken. Many swarm concepts include a leader, a command node that assigns roles, shares targeting updates, and keeps timing tight. Think of it as the conductor of an orchestra. Remove the conductor and the music can continue, but it becomes messy fast. Electronic warfare can target that conductor by isolating it, flooding its receiver, or feeding it bad information. If the leader's decisions degrade, the entire group can lose coherence. But attackers know this weakness. They can distribute leadership, rotate command roles, and add redundancy so the swarm does not collapse when one node is removed. So the command node is a high-value lever, not a guaranteed win. A defender should grab it when it appears, but never bet the ship on the assumption that the swarm has a single throat. Satellite navigation is a common target because it is a shared dependency. If you deny it, you can degrade accuracy, disrupt timing, and push drones into fallback behavior. That alone can widen dispersion and weaken simultaneous arrival. But satellite denial is not a universal stop button. Many drones can keep moving with inertial navigation, pre-programmed routes, or mixed guidance that does not rely on satellites for every second of flight. The realistic win is friction. You make the swarm less perfect. You force more drift, more delay, more uncertainty in the attacker's own geometry. You do not always make drones vanish. You make them arrive wrong. There is uncertainty because exact platform behavior varies and is not always public. The stable truth is that denial can be significant, but smart designs reduce dependence on a single navigation source. Inertial navigation is the drone's inner ear. It measures motion and estimates position without receiving outside signals. That makes it naturally resistant to satellite denial and link denial. Its weakness is drift. Small errors accumulate, especially over time, distance, and aggressive maneuvering. That is why denial can still help indirectly. It forces longer reliance on internal estimates, increasing the chance the swarm's timing and geometry degrade. But drift is not guaranteed to save you. Modern inertial systems can be accurate enough for short missions. Some drones blend inertial navigation with other cues that reduce drift. Some accept reduced precision because saturation is their weapon, not pinpoint accuracy. So a defender uses a layered mindset. Deny what you can, degrade what you cannot deny, and treat every second gained as fuel for the hard kill layers. If a drone can navigate like a person walking home by landmarks, denial becomes less decisive. Terrain contours, coastlines, visual features, even simple horizon and motion cues can help a drone stay oriented when signals are messy. This is why the real fight is broader than radios. The goal is to disrupt the guidance story. If the drone uses vision, then decoys, signature management, obscurance, and confusion in the visual domain become part of the same battle for perception. Not every swarm has this sophistication. Capability varies widely, and many details are not public. But the trend is clear. Autonomy and multi-sensor navigation reduce dependence on clean external signals. So the defender cannot rely on one denial technique. The swarm will evolve to step around single points of failure. Radar is echo listening. You send energy, it bounces back. You measure time and angle. Electronic warfare can deny those echoes with noise or deform them with deception. In a swarm scenario, small distortions matter. If tracks wobble, weapon solutions wobble. If the system cannot hold stable tracks, engagement decisions slow, and slow decisions compress the remaining timeline. Attackers can write jamming inside the swarm, creating a moving bubble of interference that masks the group and increases ambiguity. Combined with low-altitude flight and sea clutter, even a high-end sensor picture can become messy fast. Most of the time, the defender is not fully blind. The defender is half-blind, like running with smudged glasses. And in modern naval combat, half-blind can be enough for disaster if it lasts at the wrong moment. A decoy does not need to outrun a missile. It needs to attract one. That is the economic heart of deception. You spend expensive interceptors on cheap objects, and the swarm wins by making your magazine run out early. Deception scales in swarms. A false cluster can overload tracking resources. A fake leader can pull priority away from real warheads. A ghost target can force a system to reassign weapons mid-flight. This is where discipline becomes survival. You need skepticism without paralysis. If you verify everything, you run out of time. If you trust everything, you run out of interceptors. Electronic warfare is not only about confusion. It is about forcing the defender to spend limited resources on problems that were engineered to be cheap for the attacker. Electronic warfare is fought in the same spectrum your own systems use. Aggressive denial can interfere with friendly communications, navigation aids, and sensor fusion if used carelessly. There is also a psychological trap. When the picture gets noisy, teams want to turn everything on. More power, more transmissions, more jamming. That can create more noise, more confusion, and more self-inflicted friction. Real doctrine often prefers controlled, targeted use. Spend power during critical windows. Use techniques that shape the battle rather than blanket it. Avoid becoming readable, because predictable emissions can be exploited by probing attackers. In swarm combat, panic can be a faster killer than the first drone. The defender must not drown in its own countermeasures. A smart attacker does not always open with the main wave. It probes. Small groups test your reactions. What sensors light up? What frequencies you deny? What weapons you prioritize? How fast you commit? Each reaction is information. If you respond loudly and predictably, you reveal thresholds. If you jam the same way every time, you reveal habits. If you spend premium interceptors early, you reveal your fear. Defenders try to avoid being readable. They vary responses. They use decoys of their own. They sometimes hold fire, not out of weakness, but to avoid showing the rhythm the swarm wants to exploit. Details vary, and many techniques are not public, but the principle is stable. Predictable systems get punished, and probing is how attackers find the predictable parts. A realistic promise of electronic warfare is 3 verbs: degrade, desynchronize, disrupt. Degrade the quality of the swarm's information. Desynchronize the timing that makes it overwhelming. Disrupt the links that let it behave like one. If you achieve those 3, you may not eliminate the threat, but you change the shape of the problem. The defense timeline becomes breathable. The kill chain becomes more stable. Hard kill layers face fewer simultaneous choices. This is why success can look quiet. The room stays functional. Callouts stay short. Tracks remain trackable. You do not see victory. You feel it in the absence of collapse. In a world obsessed with explosions, the quiet win is often the most valuable win. The nightmare is not that denial does nothing. The nightmare is that denial triggers autonomy across the swarm, and now many drones continue inbound without needing to listen. In that case, the swarm may lose some coordination, but it still arrives in numbers. If the plan was always to saturate by volume, reduced precision may not reduce lethality enough. This is where the defender must be honest. Electronic warfare is not a substitute for hard kill layers. It is a layer that can buy time and reduce density, but guns, missiles, and close-in systems still have to finish what survives the fog. The goal is not to bet everything on one layer. The goal is to make every layer cheaper, faster, and more likely to succeed. There is a moment in every saturation event when the room shifts. Voices get quieter. Movements get more deliberate. People stop discussing possibilities and start calling actions. That shift can happen because electronic warfare works enough to stabilize the picture. The wave fractures, tracks become physical again, and the team can breathe. Or it can happen because electronic warfare fails, and the swarm stays coherent through the noise, forcing the team into raw timeline management. Either way, the defining stress is the same. What can you trust? And how long can you keep that trust alive? Trust is not comfort. Trust is the minimum certainty required to act. In a blindfold war, you do not need perfect vision. You need usable vision and the discipline to act before the last second steal your options. If you zoom out, electronic warfare is a contest over the decision loop. The swarm tries to speed its loop up and slow yours down. The defender tries to keep its loop stable, even when the picture is noisy and the clock is loud. That is why the best outcome is not the swarm stopped. It is the swarm arrived wrong. Wrong timing, wrong spacing, wrong confidence. Anything that breaks simultaneity turns catastrophe into a problem with edges. In the next stretch, we move into the endgame. What defenders do first, what attackers do last, and why the final minutes are less about hardware and more about discipline under uncertainty. Because when the spectrum turns hostile, survival belongs to the side that can keep acting, even while half blind. In modern naval defense, soft kill means you stop the threat without physically destroying it. You jam it, confuse it, break its guidance, or fracture its coordination. Hard kill means you destroy it with a weapon, a missile, a gun burst, or a close-in system. Electronic warfare lives mostly in soft kill territory. It tries to make drones miss, hesitate, arrive late, or arrive alone. Soft kill is attractive because it can scale. One technique can affect many threats at once. Hard kill is finite. Every interceptor fired is inventory that cannot be replaced in the middle of the fight. Every burst of close-in fire is time and heat and mechanical wear. Hard kill is still essential, but it is a last line, not a strategy by itself. The realistic playbook is not soft instead of hard. It is soft first, hard last. Soft kill buys time and reduces density. Hard kill finishes what survives the fog. When the picture gets noisy, people crave certainty. The best crews do not chase certainty. They ask two questions that create usable clarity. First, what does this swarm rely on? Second, what happens if we remove that reliance? If the swarm relies on a data link, denial and disruption can fracture coordination. If it relies on satellite navigation, denial can distort timing and spacing. If it relies on a command node, isolating that node can turn orchestration into chaos. But the second question is the lifesaver. If denial triggers autonomy, the threat does not disappear, it changes behavior. If denial triggers loitering, you may create a later wave. If denial triggers return to base, you may actually end the attack. Those two questions do not remove fear, but they turn fear into a sequence of decisions. Under stress, the instinct is to turn everything up. More radar power, more jamming, more transmissions. It feels like turning on headlights in fog. But the spectrum is shared terrain. More power can create more self-inflicted interference. More emissions can reveal your posture to an attacker that is probing for patterns. More noise can force your team to spend more time verifying what is real. The disciplined approach is selective. You radiate when it buys you something. You jam when it breaks timing. You deceive when it forces the attacker into wrong geometry. You keep options in reserve for the moment that matters most. In a blindfold war, waste is invisible until it becomes fatal. When deception enters the picture, defenders rebuild trust by cross-checking. If one sensor says a track is real but another disagrees, suspicion rises. If multiple independent sources agree, confidence rises. Correlation can be machine-driven and human-driven. Machines compare signal behaviors. Humans notice unnatural patterns, spacing that looks too perfect, movement that looks like a trick, clusters that appear exactly where panic would be maximized. Correlation is not proof. It is a way to decide where to spend attention. You cannot verify everything, in a saturation event. You verify what matters most, what is closest, what is fastest, what could be guiding the rest. The goal is not perfect truth. The goal is enough truth to keep the timeline alive. A decoy does not need to survive forever. It only needs to win one moment of priority. If a cheap object attracts a premium interceptor, the attacker just traded pennies for gold. Deception can create ghost targets that steal tracking resources. It can make harmless objects look urgent. It can make a real threat look less real, pushing it down the priority list until it is too late. This is where magazine depth and information depth collide. You can run out of missiles because you ran out of trust. You can waste inventory because you chased ghosts. The discipline is skepticism without paralysis. You act fast, but you do not act blindly. Imagine the timeline compressing. The swarm is inbound, and the first wave includes jammers and decoys. The track picture becomes messy, not dark, messy. The crew uses targeted denial first. They pressure the suspected coordination links and satellite receivers. They watch for behavior changes, spacing, widening, timing drifting, group splitting. If the swarm fractures, hard kill becomes efficient. Interceptors are allocated to real threats, with fewer simultaneous decisions. Close-in systems face smaller clusters instead of a single wave. If the swarm does not fracture, the crew shifts posture. They assume autonomy. They accept that denial will not stop movement, and they prepare for dense arrivals while still using the spectrum to reduce coherence where possible. Autonomy reduces dependence on clean signals, but it does not remove all dependencies. Autonomous drones still rely on sensors, timing, and internal estimates. They still have limits, drift, confusion near the target, misidentification, and imperfect coordination. Electronic warfare in that world becomes shaping. You degrade what the drone senses. You distort timing. You reduce the swarm's ability to arrive as one synchronized organism. You force more individual behavior. Even a small reduction in simultaneity can matter. Saturation is not a binary switch. It is a slope. If you can push the slope down, you can pull the defense back above water. Autonomy raises the bar, but it does not erase the battlefield in the spectrum. Every defense system has a loop. See, decide, act. The swarm attacks that loop by speeding its own loop and slowing yours down. Noise slows you. Lies slow you. Too many choices slow you. Electronic warfare is the counter, not because it guarantees shutdown, but because it can slow the swarm's loop and stabilize yours. If the swarm loses coordination, it spends time reorganizing. If its navigation becomes less reliable, it arrives less cleanly. A stable decision loop is the difference between a ship that stays procedural and a ship that becomes reactive. Reactive means spending without thinking. Procedural means surviving long enough for the timeline to end. Protecting the loop is the quiet hero work of modern combat. Deception is not only technical, it is psychological. Under stress, people crave a simple story. Deception often offers exactly that, a convincing wrong answer that feels clean. Good crews train for discomfort. They practice operating with incomplete data. They practice saying, "We do not know everything, but we must act anyway." That sentence sounds simple, but it is a skill. They also practice roles and authority. Short call-outs, clear priorities, fewer debates. Under saturation pressure, the room must share one coherent story, even if that story includes uncertainty. The swarm tries to fracture the team's shared reality. The team survives by protecting it. Because you fight in the same spectrum you use, countermeasures can create friendly confusion. Aggressive denial can interfere with friendly links. Heavy emissions can make your own picture harder to interpret. This is why doctrine prefers controlled use. You select techniques that buy time without drowning your own systems. You avoid turning the spectrum into a fog you created and cannot navigate. There is a hard lesson here. If the defender panics and turns everything on, the defender can become its own jammer. The swarm does not need to be perfect if you help it. Electronic warfare is power, but power without discipline becomes self-harm. When electronic warfare works, it often feels like the room stays normal. The picture is not perfect, but it becomes usable. Tracks stabilize. Confident priorities emerge. The callouts stay short. The swarm may still be inbound, but it arrives less cleanly. Timing breaks. Spacing widens. The wave becomes several smaller problems instead of one overwhelming moment. That is the quiet win. Not nothing happened, but the collapse did not happen. In saturation math, avoiding collapse is the whole point. If you want a single phrase, electronic warfare does not always stop the attack. It stops the attack from arriving perfectly. The loud loss is when the decision loop breaks. The room becomes reactive. Every track looks urgent. Every choice feels late. Inventory drains, attention drains, and confidence drains. Deception accelerates this by creating too many plausible threats. Denial accelerates it by forcing verification. Autonomy accelerates it by removing your ability to influence the swarm through clean signal denial. Preventing the loud loss means keeping the loop stable. It means accepting uncertainty without freezing. It means using the spectrum to buy seconds, not to chase perfection. In a blindfold war, you do not need to see everything. You need to avoid becoming blind in your own head. We know the principles. Denial can reduce coordination. Deception can drain resources. Disruption can break simultaneity. We know that autonomy and redundancy reduce dependence on any single signal source. We do not always know the exact capabilities of specific swarms. Some details are classified. Some are exaggerated in public discussions. Some are underestimated because failures are not advertised. That uncertainty matters because it forces a defender to build flexible doctrine. You plan for both. You assume the swarm could be fragile, and you assume it could be resilient. You build layers that work in either case. Realism is not pessimism. Realism is a form of readiness. If you want the practical playbook in one sentence, it is this. Use electronic warfare to degrade the swarm's information, desynchronize its timing, and disrupt its coordination, then let hard kill finish what survives. That sentence is not flashy, but it is honest. It accepts that there is no single miracle layer. It treats the spectrum as terrain, not magic. It treats the fight as timeline management, not cinematic hero moments. It also explains why the swarm era is so unforgiving. The attacker is not trying to win a duel. The attacker is trying to collapse your decision loop. Your job is to keep that loop alive until the last second passes. Now we move into the closing stretch, and we bring the story back to the room, the screens, the quiet, and the final decision. There is a moment, right before the last window closes, when everything becomes simple. Not because the picture is clear, but because there is no time left for complexity. By then, electronic warfare has either shaped the fight enough to keep the wave fractured, or it has failed to stop coherence, and the swarm is arriving dense. Either way, the crew must commit. This is where layers matter. Soft kill bought what it could. Now hard kill must act without hesitation. If the room stayed procedural, this moment feels like execution. If the room became reactive, this moment feels like desperation. The difference was never one switch. The difference was discipline across minutes when seconds were being stolen. A blindfold does not mean darkness. It means partial truth. It means a picture that is good enough in places and unreliable in others. That is what the spectrum fight creates. The attacker wants you to swing at shadows. The defender wants to keep enough trust to swing at real targets. That is the entire war. Inside the war, electronic warfare is the tool that can remove coordination without removing the platforms. It can make a swarm arrive wrong. It can make the attacker waste time instead of you. It can keep your loop from collapsing. And when it fails, the lesson is the same. You never bet the ship on one layer. You bet the ship on the stack. Winning this kind of fight costs discipline. It costs training that makes uncertainty feel normal. It costs procedures that keep the room coherent when the picture becomes messy. It costs restraint, not turning every emission up just because fear demands action. Losing costs something worse. It costs your decision loop. Once the loop collapses, everything becomes expensive. Missiles wasted, time wasted, and attention shattered across ghosts and decoys. The swarm does not need perfection. It needs you to spend wrong. So the true economics of electronic warfare are not only about hardware. They are about which side spends its limited resources, missiles, seconds, trust, on the right things. Now we end this story cleanly, with 3 segments that lock the lesson into memory. First, it can break coordination. If the swarm relies on links and shared timing, you can fracture it into individuals. That alone can turn an overwhelming wave into a manageable sequence. Second, it can break simultaneity. Even when drones keep coming, denial and disruption can widen spacing and desynchronize arrivals. In saturation math, desynchronization is oxygen. Third, it can protect your decision loop. By reducing deception effectiveness and stabilizing enough of the picture, you keep the room procedural instead of reactive. You keep trust from collapsing. Those 3 wins are not guaranteed, but they are the realistic reasons. Electronic warfare belongs at the center of the counter-swarm playbook. Electronic warfare fails to stop the swarm when the swarm does not need the signals you are denying. Autonomy, inertial navigation, and pre-programmed routes shrink the miracle. The drones keep moving, even through noise. When that happens, the goal shifts. You stop chasing total shutdown, and you chase shaping. You still try to degrade timing and coherence. You still try to reduce density. But you prepare hard kill layers to carry the final burden. This is where layered defense becomes real. Soft kill buys seconds. Hard kill spends those seconds well. The ship survives not because one layer was perfect, but because the stack worked together under pressure. In a blindfold war, you win by acting with discipline while half blind, and by never confusing a helpful layer with a guaranteed shield. Back in the Combat Information Center, the screens still glow blue. The air is still dry. The timeline still feels like it is running downhill. But the room has one job: keep the decision loop alive. Electronic warfare is the fight over perception. It can deny, deceive, and disrupt. It can stop some swarms without a shot. It can fail against others that keep moving without signals. The truth sits between hype and fear. So the lesson is simple and brutal. You do not need perfect vision. You need usable trust. You degrade the swarm's information, desynchronize its timing, disrupt its coordination, and you use the seconds you buy to let the rest of your layered defense do its job. Because the swarm does not win by being invisible. It wins by making you hesitate. And the defender survives by trusting enough to act before the last seconds steal the option to choose.